Hello everyone. I am Fazamus Khan from Sri Venkateshwara College of Engineering, Bengaluru. In today's video, I'll be discussing about a topic under mathematics, which is angles, projections, and transformations. In today's video, we'll be discussing about angles and projections, rotation, reflection, contraction and expansion, applications, architecture, video games, and photography, and some real world examples, astronomy, and engineering. Welcome to the world of angles and projections, rotation, reflection, contraction, and expansion. These concepts may seem complex, but they play a crucial role in many fields, from mathematics and physics to architecture and photography. By understanding these concepts, you will gain a deeper appreciation for the world around us. Throughout this presentation, we will explore the basics of angles and projections, as well as more advanced concepts such as rotation, reflection, contraction, and expansion. We will also examine real-world examples of how these concepts are used in fields such as astronomy, engineering, and video game design. Angles and projections are fundamental concepts in mathematics and physics. An angle is formed by two rays that share a common endpoint, while a projection is the image of an object formed on a surface by lines that pass through a fixed point. These concepts are used extensively in a variety of fields, including engineering, architecture, and photography. In engineering, angles and projections are used to design and build structures and machines. Architects use these concepts to create visually appealing buildings and spaces, while photographers use them to capture stunning images. For example, in photography, the angle at which a photo is taken can greatly affect the final image. By changing the angle, a photographer can create a sense of depth or emphasize certain elements of the scene. Rotation is the process of rotating an object around a fixed point or axis. In mathematics, rotation is used to describe the movement of objects in two and three-dimensional space. In physics, rotation is used to describe the movement of particles and rigid bodies. One real-world application of rotation is in sports. For example, when a figure skater performs a spin, they are rotating their body around a fixed point. Another example is in the manufacturing industry, where machines use rotational motion to shape and cut materials. Next is reflection. It is a phenomena in which waves, such as light or sound, bounce off a surface and change direction. In mathematics and physics, reflection is used to study the behavior of waves and to understand how they interact with different materials and surfaces. One real-world example of reflection is in mirrors. When light waves hit a mirror, they reflect off the surface and create an image of whatever is in front of the mirror. This is because the angle of incidence is equal to the angle of reflection. Another example is in sonar technology, where sound waves are reflected off underwater objects to determine their location and size. Coming on to contraction and expansion. In mathematics and physics, contraction refers to the shrinking of an object or space, while expansion refers to the opposite, the stretching or enlarging of an object or space. These components are commonly used in fields such as geometry, calculus, and mechanics. One example of how contraction and expansion are used in real world applications is in the design of bridges and buildings. Engineers use these concepts to determine how materials will behave under different conditions, such as changes in temperature or pressure. By understanding how materials contract and expand, Engineers can design structures that are more resilient and less likely to fail. The first application is architecture. It is a field that heavily relies on the concepts of angles and projections, rotation, reflection, contraction, and expansion. These concepts are used to design buildings that not only look aesthetically pleasing, but also serve their intended purpose. For instance, angles and projections are used to create unique shapes and designs that make a building stand out from its surroundings. Rotation is used to create dynamic spaces that change as one moves through them. Reflection is used to create illusions and enhance the visual appeal of a building. Contraction and expansion are used to control the flow of light and air within a building. Famous buildings that use these concepts include Sydney Opera House in Australia. The building's distinctive sail-like shape was achieved through the use of rotation and reflection. The second application is video games. In video games, angles and projections are used to create the illusion of depth and perspective. For example, a first person shooter game may use a perspective projection to create the feeling of being inside the game world. This type of projection creates the illusion of depth by making objects that are closer to the player appear larger than the objects that are farther away. Rotation is also used in video games to create movement and animation. For instance, a character in a platformer game may rotate as they jump or perform an attack. Reflection is used to create mirrored images and can be seen in racing games where cars are reflected on the surface of the track. Contraction and expansion are used to create the illusion of movement and speed, such as in racing games where the environment appears to move faster as a player's car accelerates. In photography, angles and projections are used to create interesting and dynamic compositions. By changing the angle of the camera or lens, photographers can create unique perspectives that draw the viewer's eye into the image. For example, a long angle shot can make a subject appear larger and more imposing, while a high angle shot can make them appear smaller and more vulnerable. Rotation, reflection, contraction, and expansion can also be used to create interesting effects in photography. Rotating the camera while taking a photo can create a sense of motion or blur, while using reflections can add depth and complexity to an image. Contraction and expansion can be used to distort the perspective of an image, creating surreal and dreamlike compositions. Real-world examples include astronomy. In astronomy, angles and projections are used to measure the positions and movements of celestial objects. Rotation is used to describe the spinning motion of planets and stars, while reflection is used to study the light that is emitted or reflected by these objects. Contraction and expansion are used to explain phenomena such as the expansion of the universe. For example, astronomers use angles and projections to map the positions of stars and galaxies in the sky. By measuring the angles between these objects and projecting them onto a two-dimensional map, astronomers can create detailed star charts and maps of the universe. Rotation is used to study the rotation of planets and stars, which can provide important information about their composition and behavior. Reflection is used to study the light that is emitted or reflected by celestial objects, which can reveal their temperature, chemical composition, and other properties. Finally, contraction and expansion are used to explain phenomena such as the redshift of distant galaxies, which provides evidence for the expansion of the universe. Another real-world example is engineering. Angles and projections are used to create accurate designs and blueprints for structures and machines. By using precise measurements and calculations, engineers can ensure that their creations will function properly and safely. Rotation is also a crucial concept in engineering, as it allows engineers to design moving parts that function smoothly and efficiently. Reflection can be used to create mirror or reflective surfaces in machines, while contraction and expansion are important in understanding how materials behave under different conditions. In conclusion, understanding angles and projections, rotation, reflection, contraction, and expansion is crucial in various fields such as architecture, engineering, photography, and astronomy. These concepts are used to design and build structures and machines, capture stunning photographs, explore the universe, and create immersive video games. By learning about these concepts, you can gain a deeper understanding of how the world around us works and how we can use these principles to innovate and solve complex problems. So, I encourage you to continue learning and exploring these fascinating topics. Thank you.